The statement that one should question information before accepting it is accurate and highlights the importance of critical evaluation. It's crucial to examine sources and assess the validity of claims, whether encountered in print or online. In the context of electrical diagrams, such as those involving transformers, careful scrutiny is essential. A complete transformer diagram should clearly indicate the voltage relationships between all relevant points. In a three-phase system, this includes the voltage between phases A and B, and phases A and C, in addition to phase-to-neutral voltages if applicable. The absence of such information makes the diagram incomplete and potentially misleading. When analyzing any diagram, firstly, verify that all relevant parameters are included. Secondly, check the consistency of the information presented. Thirdly, ensure that the diagram adheres to established conventions and standards. For example, in electrical diagrams, voltage polarities and current directions should be clearly indicated. Similarly, the transformer winding connections, such as delta or Y, should be explicitly shown. A complete transformer diagram should include the following information. 1. The transformer's kVA rating, which represents the apparent power that the transformer can deliver or handle. 2. The primary and secondary voltages, which are the rated input and output voltages of the transformer. 3. The winding connections, which indicate whether the primary and secondary windings are connected in delta or Y configurations. 4. The impedance, which is the opposition to the flow of alternating current and affects voltage regulation and short-circuit current levels. 5. The tap settings, which allow for adjustments to the turns ratio and output voltage. 6. The phase relationship, which indicates the phase difference between the primary and secondary voltages in polyphase transformers. 7. The insulation class, which specifies the maximum operating temperature of the transformer's insulation. 8. The standards compliance, which indicates that the transformer meets relevant industry standards such as those from the Institute of Electrical and Electronics Engineers, or IEE, and the National Electrical Manufacturers Association, or NEMA. 9. The vector group, which describes the phase displacement between the primary and secondary windings in three-phase transformers. 10. The cooling method, which specifies how the transformer is cooled, such as oil-filled, self-cooled, or forced air-cooled. 11. The nameplate information, which includes the manufacturer's name, model number, serial number, and other identifying details. If any of these elements are missing, the diagram should be questioned. Incomplete or inaccurate diagrams can lead to misunderstandings, miscalculations, and potentially dangerous situations. Always cross-reference information with reliable sources and consult with qualified professionals when necessary. When evaluating information from any source, consider the following points. Firstly, assess the source's credibility. Look for established authorities, reputable organizations, or experts in the field. Secondly, check for bias. Be aware of potential biases that may influence the information presented. Thirdly, verify the information. Compare the information with other sources to confirm its accuracy. Fourthly, evaluate the evidence. Look for supporting evidence such as data, research findings, or case studies. Fifthly, consider the context. Understand the context in which the information is presented to avoid misinterpretations. Sixthly, question assumptions. Identify and question any underlying assumptions that may affect the validity of the information. Seventhly, look for logical fallacies. Be aware of common logical fallacies that may be used to manipulate or mislead. Eighthly, stay informed. Keep up to date with the latest developments and research in the field. Ninthly, be skeptical. Approach information with a healthy dose of skepticism, especially when it seems too good to be true. 10thly, think critically. Engage in critical thinking by analyzing, evaluating, and synthesizing information to form your own informed opinions. In the absence of complete and accurate information, it is impossible to make informed decisions or draw valid conclusions. Therefore, it is crucial to question the information and seek clarification or additional details when necessary. For example, when analyzing a transformer diagram, consider the implications of missing voltage values. The voltage between phases A and B and phases A and C are essential for determining the overall voltage balance and power distribution in a three-phase system. Without these values, it is impossible to calculate the line currents, phase angles, and power factor. Similarly, the absence of neutral voltage information can affect the grounding and safety of the system. In such cases, it is important to request the missing information from the source or consult with a qualified electrician or engineer. Additionally, it is important to consider the purpose of the diagram. Is it intended for design, installation, troubleshooting, or training purposes? The level of detail required may vary depending on the intended use. For example, a design diagram may need to include more detailed information about the transformer's internal components and construction, while a troubleshooting diagram may focus on the external connections and voltage measurements. Regardless of the purpose, the diagram should always be clear, accurate, and complete. In conclusion, critical evaluation is essential when assessing information from any source. Question assumptions, verify facts, and consider the context in which the information is presented. In the case of electrical diagrams, such as those involving transformers, ensure that all relevant parameters are included and that the diagram adheres to established conventions and standards. By adopting a critical mindset, it is possible to avoid misunderstandings, miscalculations, and potentially dangerous situations. Remember that the completeness and accuracy of information are crucial for making informed decisions and ensuring safety.